All right, so now we're on to the second page of 3.4. So let's work on this one. We need to find the common denominator. So this one is 1 over 1. The common denominator between 8p plus 3 and 8p plus 3 and 1, since these are the same and this is just 1. 1 can multiply times 8p plus 3 to get that desired denominator. So 8p plus 3 is our common denominator. Now we multiply it across the top here. So 1 times 8p plus 3 is 8p plus 3. And then we have p minus 5 times 8p plus 3. Make sure to put parentheses around both of those. Over, and then it'd be 8p plus 3. Let's put parentheses around all of them, just so we can acknowledge that they're factors. And then that's equal to 8p plus 3 over 1. Okay, so the 8p plus 3's cancel out on the top and the bottom, so it just ends up being 1, and then minus, and then the 8p's cancel out on the top and the bottom. We get p minus 5. And then that's equal to 8p plus 3. All right, if I distribute the negative in here, I get 1 minus p, and then negative of a negative is a plus, so plus 5 is equal to 8p plus 3. And then I just go through my solving algorithm. So I'm going to add p to both sides. So I get, let's see, 1 plus 5, so 6 is equal to, and then 8p plus 1 is going to be 9p plus 3. Subtracting 3 from both sides, we get 3 is equal to 9p. And then dividing both sides by 9, we get p is equal to 3 over 9, which reduces down to 1/3. So there's our solution. Let's check for extraneous solutions. We go back over to our domain. Let's see here. So these ones have p in them, so we need to make sure that 8p plus 3 cannot be equal to 0. So subtract 3, 8p cannot be equal to negative 3. Divide by 8, p cannot be equal to negative 3/8. And, you know, that's not what it's equal to. So, again, we have no extraneous solutions. Hope we come across a couple of them soon, because so far this hasn't really been an issue yet. Okay, next let's go to number 11. So 11, let's factor the bottom part. It doesn't look like this is going to factor. Let's see, 210 and then 29. Yeah, I don't think it's going to factor, but I don't really honestly care, because I'm not really going to be needing this anyways. I'm going to be combining like terms, so it doesn't matter. But factoring the bottom will help out a lot. If I have a squared minus 6a, that turns into a times a minus 6. So, like, you know, you can kind of, as long as you're multiplying across the top, you're good to go. So just if you find the common denominator, just, you know, business as usual. If you notice this a minus 6, if I multiply that by a, I get this denominator. And if I take this a and multiply it by a minus 6, I get this denominator. So that means that the common denominator is this thing. An easy way to kind of tell that is if you factor it and it has the other denominators in it, that's just going to be your common denominator. So my common denominator in this case is a times a minus 6. So I multiply that in the top, all right? So I'm just going to rewrite it. A times a minus 6 times 1 is just itself over a minus 6. Those a minus 6's are obviously going to cancel out. Equals 7 times a minus 6 over a. So the a's will cancel out. Minus, and then this big thing, 5a squared minus 29a minus 42, and then times a, oops, we did not put the parentheses on there just to keep it consistent. So a times a minus 6, and that's all over the denominator here, a times a minus 6. All right, so then try and cancel out as much stuff as possible. The a minus 6's cancel out. So just have a is equal to, and then let's see here, the a's cancel out. So I have 7 times a minus 6. And then the a and the a minus 6's cancel out, so we have minus, parentheses, 5a squared minus 29a minus 42. Man, this is a beast. Distribute the 7 in there. A is equal to 7a minus 42. Distribute the negative in there. Negative 5a squared plus 29a plus 42, because the negative changes all the signs in here. Now, combine like terms. Let's see what we have. So a is equal to, and then we have a negative 5a squared, and then negative 42 and 42. Those just cancel out because they add up to 0. And then 29a and 7a adds up to 36a, so plus 36a. Now I'm going to subtract an a from both sides, and I get 0 is equal to negative 5a squared plus 35a. Okay, now I have to factor this stuff, so let's see. Negative 5a squared and 35a are both divisible by 5, and they're also divisible by a. So I'm going to take both of those out of there. If I divide this by 5a, I get negative a. If I divide this by 5a, I get plus 7. All right, and then if that's equal to 0, then my solutions for A are, let's see here. So 5A equals 0. That means that A equals 0 is one of my answers. And then if I have negative A plus 7 is equal to 0, if I add A to both sides, I get 7 equals A. So there's my other answer. Now let's check for extraneous solutions. So I go back to the denominators. For A minus 6, that can't be equal to 0. So that means that A cannot be equal to 6. No big deal, because neither of those are 6. And then this denominator of A can't be equal to 0. Uh-oh, A equals 0. So this one is an extraneous solution on it. This solution works out 7. So A equals 0, extraneous. A equals 7 works out. All right, a couple more problems, then we're all done. So number 13, factor the bottom. Actually, it doesn't look like we need to, yeah, we should factor the bottom, so then we know the domain. So x squared minus 2x, we have in common here and here, so that turns into x times x minus 2. Oops, there we go, x times x minus 2, there we go. All right, so that's our common denominator because the only other number is 1, so we multiply that in the top, we get 3 times x minus 2 over x times x minus 2 equals 1, so that's, oops, that's 3. So that's x times x minus 2 over 1 plus, and then we have x minus 3 times x minus 2 all over that, which is x times x minus 2. All right, start canceling stuff out. The x's cancel, the x minus 2's cancel, so 3 is equal to, this over 1 is just itself, so x times x minus 2 plus, and then the x's cancel, the x minus 2's cancel, so that's just x minus 3. All right, so I'm going to distribute the x. 3 is equal to x squared minus 2x, and then plus x and minus 3. Combining like terms, so if I subtract 3, that gives me 0 is equal to x squared, and the negative 2x plus x is negative x. Negative 3 minus 3 is negative 6, and I'm pretty sure that factors. Numbers that multiply together to be negative 6, add together to be negative 1, that's going to be negative 3 and positive 2. So that means that my x values are going to be 3 from this one and then negative 2 from this one. Okay, so then let's go back and see which ones we can't have. So if I just take that denominator of x times x minus 2, it cannot be equal to 0. So that means that x cannot be equal to 0, and then x minus 2 cannot be equal to 0, so x can't be 2. And it looks like neither of those are part of that. So that means that both of these check out. There are no extraneous solutions here. All right, now for the last one, number 15, and then that'll be the end of this video, and we'll go on to 3.5, the word problems. All right, number 15, factor the bottom. So b squared minus 4 is a famous one. We use it over and over again. That's the difference of squares problems. So we have b plus 2 and b minus 2 for both of those denominators. And obviously, since we have a 1 right here, that's just 1 over 1. So our common denominator is going to be b minus 2, b plus 2. So we multiply that in the top for both of these. So on the top here, we have b plus 2, b minus 2 times 1 over b plus 2, b minus 2. So all that stuff is going to cancel out, it looks like. Equals b plus 3, that's that, times the denominator, which is b minus 2, b plus 2, all over that, which is b minus 2, b plus 2. And we have plus 1, so 1 times b plus 2, b minus 2 over 1. So, that's just going to stay the same. So let's see what cancels out. The b plus 2's, the b minus 2's, so this just turns into 1 is equal to the b minus 2's, and the b plus 2's cancel out, so b plus 3 plus, and then we have b plus 2, b minus 2. And remember that factors to be b squared minus 4, so I'm just going to change that back to a b squared minus 4. Okay, now let's combine like terms. So subtracting 1. Well, let's do it one piece at a time. So subtract 1 from both sides, so you get 0 is equal to b plus 3 plus b squared minus 4, and then minus 1. And then combining and rearranging, we get b squared plus b, and then 3 minus 4 is negative 1, and negative 1 makes negative 2. I can factor this expression because the numbers that multiply together to be negative 2 and add together to be 1 are 2 and negative 1. So this becomes b plus 1, oh, sorry, b plus 2, and then b minus 1. Sorry about that. All right, and then solving, so b plus 2 equals 0, that means b equals -2. b minus 1 equals 0 means that b equals 1. All right, so these are my two solutions. Let's see if any of them are extraneous. So if I go back over to the denominator, b minus 2, b plus 2, that can't be equal to 0. So if each part can't be equal to 0, that means that from here, b can't be equal to 2, and then from here, b can't be equal to -2. And check it out, we've got one of those right over here. So this ends up being an extraneous solution, but this one checks out just fine because, you know, can't be 2 and can't be -2. So that's why it's like that. All right, so this is the back page. This is the toughest stuff, by the way. So if this came pretty easy to you, then you know you're doing pretty well. If this was really difficult, you know, we have a bunch more that you can practice, the evens, and you know, just keep working on that. All right, so if you need some help on this stuff, don't forget to reach out to your teacher. The next video is going to focus on 3.5, the word problems.